When looking at the greater Detroit region, it's obvious how the river has influenced the development of the city, but also how the development of the city has affected the river and its ecosystem. Sitting just south of Detroit is Bellinger Park, an ideal location to explore the design implications of the relationship between reconciling the past and planning for the future of this region. Beginning in 1874, both the St. Clair River and Detroit River were extensively modified. The river bottoms were dredged to create deep channels for large commercial ships. The dredging and disposal of dredged materials such as dirt, sediment, and rocks changed the flow of the river and damaged the natural limestone reefs where millions of fish spawned. These and other impacts, including overfishing and shoreline development, have dramatically reduced the populations of native fish, particularly lake sturgeon. To help remediate the lost habitat, I've implemented an artificial reef system. These modular reefs are designed to be adjusted in clusters of varying shapes and sizes. In contrast to existing artificial reef projects, these reefs are raised to prevent sediment buildup due to the turbidity and heavy shipping use of the Detroit River. This allows the crevices where fish lay their eggs to remain available. In addition, the limestone inserts are sized between 4 and 8 inches to discourage their use by invasive species such as sea lamprey, who prefer smaller crevices. To determine a suitable location to employ these artificial reefs, the necessary factors of water velocity, depth, and both proximity to primary shipping lanes and existing habitat were combined. As you can see in a dark green, the coast off Bellinger Park has near to ideal conditions for a new reef restoration project. As we move from focusing on past remediation and into future planning, the most imminent threat for Bellinger Park becomes Detroit River water level fluctuations due to climate change. The climate change implication predictions for the Great Lakes are much different than the oceans and perhaps more complex. While cyclical variations in Great Lakes water levels is usual, climate change predictions show these variations to increase in both frequency and magnitude. Annual precipitation has increased significantly here in southeast Michigan, as well as average lake surface temperatures. This, combined with many complex and compounding factors, leaves coastal infrastructure with a difficult challenge. How do we plan and design for both extreme high and low water levels? And how can these fluctuating water levels be utilized as a positive and novel opportunity, and not only as an inconvenience to be engineered to prevent? The site plan for the updated Bellinger Park uses both water level fluctuations and habitat restoration as primary design drivers. This site seeks to balance past remediation and future resilience while retaining its recreational value within the community. The plan for this site includes an interconnected system of boardwalks at varying heights, a large constructed Great Lakes wetland, naturalized shorelines, artificial reefs, multifunctional inlet, recessed underwater viewing, raised pavilion, and recreational fields. An essential component to this site's flood resilience and habitat creation is the replacement of hard seawalls with a natural shoreline. Because this site's design is encouraging the rise and fall of water levels, a non-structural vegetative and cobble-based shoreline restoration is the best option. This natural shoreline will help dissipate wave energy, stabilize soils, provide wildlife habitat, and improve water quality. Coastal wetlands are especially adaptable to water level fluctuations. In fact, they are essential to maintaining these wetlands. When lake levels fall, broadleaf plants and shrubs, which are able to outgrow smaller wetland plants, begin their movement towards the shoreline. As the soil dries, the vast seed reserves that have been laying dormant receive the oxygen they need and sprout. In contrast, as lake water levels rise, the flooding eliminates the woody shrubs and trees, and the wetland reclaims itself and the interior ponds fill. Incorporating this type of wetland at Bellinger Park is essential to its resilience. There are many elements within this site that have been designed to have different functions depending on water levels. When water levels are high, the lower metal boardwalk will begin to flood and allow for the transition of wetland plants. The higher boardwalk then becomes the primary circulation route for river access. Within the inlet, the artificial coral structures are fully submerged and serve as habitat for spawning fish. In contrast, when water levels are low, both the upper and lower boardwalks are exposed and add interest and complexity to the site's circulation. The inlet becomes a gathering and resting place, while the artificial reefs are exposed for human interaction and observation. The inner wetland transitions to a drier upland plant community. The future of climate change and its implications to Great Lakes water levels remains a question. In developing our waterfronts to be flexible and resilient by creating varying and interactive experiences, we can help embrace these climatic changes, could view the glass as half full, and create novel waterfronts to take us into the future.